All right, today what we want to see is area of a segment. Yeah, yesterday we saw area of a circle, area of a sector. All right, sorry for the interruption. Yesterday we saw area of a sector, that was theta by 360 into pi r square. We also saw length of an arc of a sector, theta by 360 into pi r 2 pi r. Now we're going to move into area of a segment. Okay, area of a segment. Just so that we understand conceptually what we have to find with this when we do area of a segment, I want your attention on the board, please. Okay. Now this, what do I say? What do I mean when I say area of a segment? Have your eyes on the board. Now this is a sector. Okay, this full thing is a sector. All right. P Q dala. So it is when we connect two radii, whatever is the area between the two radii and the circumference part, the arc part, is the sector. All right. Now where is the segment? How will I form the segment? How will I get the segment? What do I need to draw for that to get the segment? Yes, Dilruba? Chord. I have to draw the chord PQ. I have to join the chord PQ. All right. Now what is this part here is the minor segment. Yeah. This part here is a segment. Again, just as in sector, when we directly write segment, when you see just segment written in the question, you assume it to be the minor segment. Okay, and then you don't, if they are talking about major segment, they will say major specifically. Okay, if that's not said, it's minor segment. All right. Now in this case, this is my minor segment. Okay. Now today's class is about how do we find the area of this minor segment. Manisha, you have a doubt? You have a thought about how to find the area? Okay, tell me. We are finding this shaded part. Yeah, we are finding this part area. This is the area of the segment, right? This is the area of the segment. This shaded part is the area of the segment. Now my question is, how do you think you will find this area? Yes. Perfect. So my area of let's call this let's put this as x. So area of segment PXQ is equal to area of sector POQ minus area of triangle POQ. Is that okay? Yeah, it's basically this red area fully minus this blue area. Is that okay? Yeah, but the question becomes a little bit more challenging as to how do we find this area of triangle POQ. Okay, sector though we know. If we have the angle, we have the radius, we can find the area of the sector, right? Theta by 360 into pi r square. But how do we find the area of this triangle POQ? All right, that will be a small challenge which we have in this question. Okay, and we want to look at that first. All right, in the question which we do, we want to look at that first. We want to understand that first, and then our work is very, very easy. It's just a matter of subtraction. Everyone with me so far? All right, we'll actually just take down this diagram, so that we have an understanding of what we're going to do in the question, and then we'll continue. All right, attention on the board back again. This is a question. Example 3 is a question. Okay, we'll be running through example 3. We'll have a couple of questions and the exercises over. Okay. Now all attention on the board. Everything down. Okay, this is an important type of question, and it's not probably something which will come naturally to us also. So I need your attention on the board. Okay. If you see, they have given us radius of the circle. They have given the angle of theta of the circle of the sector. Okay. Can you find the area of the sector? We can find 120 by 360 into 21 pi r square. Okay. So r is there. We know that. We'll find it. We have to find this part now. Okay. We have to find this part now. Right. That's where the trickiness comes. Okay. It's not something which is very intuitive, but we have done something already before, and the hint is trigonometry. Okay. So I'll go over to Tulsi. Okay.
It is forming an isosceles triangle.
Okay.
So the opposite angles can be equal.
Correct. Opposite angles are equal.
Then 190 minus 120, what we get by 2 equals
30, 30. Okay. What happens now? Then what can we find? You're good. You're good. You're on the. At least you were able to find out something more about the triangle, right? But to find area, we have 2 methods and 1 coordinate geometry method, right? 3 methods we have. Coordinate geometry method will not apply here. We don't have points, right? Two methods we have, that's half base into height. The other method we have is Heron's formula, root over s into s minus a into s minus b into s minus c. Okay, we good with this? Do we have a, b, c? We have a and b, we don't have c, right? We have two sides of this triangle, we don't have the third side, correct? So we can't really use this. Base into height, we don't really have that. So definitely we need to find something more. So one way of doing it is either you find the third side, okay, and you use Heron's formula. You getting me? You already have one side, second side you find this third side, and then you use Heron's formula. Other ways, you find height and base, and then you use half into base into height. Okay, both methods are fine. But in both the situations, I will have to use some knowledge which is not like very intuitive to us. And Manisha, would you like to come in? No? Okay. You were saying the same thing. Chalo. So we'll get to this. Okay, we'll get to this business now. Here, I'm going to take this triangle separately. Okay, I'm not going to well into sector much. We will do that at the end. So separate this triangle separately. AOB. Okay. Everyone okay with this? This is 21. This is 21 centimeter. This is 21 centimeter, and this is 120 degree. All right. Now, I'm going to go to the half base into height route. Okay. You can choose to go to the Heron's formula route also. Any route is fine. Okay. But to do this, now I know that if I were to drop a perpendicular from here, what's going to happen? That perpendicular, so obviously it's going to be 90 degree. But what's going to happen because of that? Yes, it will bisect AB. Yeah, a perpendicular from the center of the circle bisects the chord. Everyone okay with that? So let's put this as M. Can I show that triangle AMB is congruent to triangle B? Sorry, AMO. AMO is congruent to triangle BMO. How can I show that? RHS, yeah. Right angle, hypotenuse, and side common. Okay, or you can also take this side. Actually, SSS also you can do. Yeah. So many methods of showing this. Everyone okay with this? Now these two triangles are congruent. Now keeping that aside, okay. If these two triangles are congruent, we'll also know that this and this is equal. All right. Now let's look at. So if I find area of one triangle, if I multiply that by 2, can I get the total area? Everyone okay with that so far? Now let's focus on this particular triangle. Okay. Let's focus only on the green triangle right now. Now if you see carefully, Tulsi already told us that this is 30 degree. Everyone can get, any of us can get that? Okay. If you don't want to think about it as 30 degree, you can you also think of this as 60 degree? Because 120 degree is split into two congruent triangles equally. 60. All right. You will be able to get to that conclusion. Either you take this 30 or you take this 60. Okay. Whichever one is comfortable for you. I am taking this 30. Okay. Taking this 30. Can you find this side? Can you find OM? How do we find OM? Opposite by hypotenuse is equal to sine 30. If you look at this particular triangle, and I want everyone to focus on only this particular triangle, okay? Triangle AMO. All right, triangle AOM. If you see, this is theta. Sine theta is what? Opposite, that is OM, by hypotenuse, that is OA. How do you feel about it, Bindu? Clear? That's all. Now, using that, I will find OM because I already know hypotenuse, right? Sine 30 also I already know. So 1 by 2 is equal to opposite by hypotenuse. Opposite is what? OM by hypotenuse is 21. So my OM is equal to 21 by 2. Everyone okay with that?
Yes.
I have got H already of the big triangle. If you want to look at the big triangle, or if for the small triangle also the same H, right? We got this. Everyone okay with that? Yeah. Now keeping that aside, can you also find AM now similarly?
Yes.
Yeah. Cos 30 is equal to AM by 21. Cos 30 is equal to base, or what do you use? Adjacent by hypotenuse. So that's equal. Cos 30 is root 3 by 2 is equal to AM by hypotenuse is 21. AM is equal to 21 root 3 by 2. Okay. So I got OM, I got AM. You can do it two ways. I'll just go to the big triangle back. Okay. Now AB is equal to how much? 2 into AM, because the perpendicular from the center bisects the chord. Okay. So this I know. This full thing is double of AM. Okay with that, Shripriya? Following me? Are you getting lost anywhere? Call me out if you're getting lost. If at any point anyone feels lost, you're going to call me out. Okay. Don't wait till me. This is a big question. Okay. So that gives me AB is equal to 2 into 21 root 3 by 2. 2 cancel is equal to 21 root 3. Everyone okay so far? AB is equal to 20 root 3 centimeter. OM is equal to so this is my basically in this half base into height. If I take area of triangle AOB, if I take this, I have this as half into base into height. My base is AB, my height is OM. Okay with that? So half into, I'll write it in terms of the sides. So half into AB into OM, that is equal to half into AB is how much? 21 root 3. 21 root 3 into OM. OM is how much? 21 into 2. 21 by 2. Okay. We good? Now it's just calculation. Area of triangle AOB is equal to 21 21s are 441 by 4 root 3. Yeah, correct. 441 by root 3 centimeter square. We good with this? That's my area of triangle AOB. Now, this is only this part area. This is only this red part area. But I have to find what? I have to find this blue part. So for that, going back to our formula here, you have to do what? You have to find the area of the sector. Okay. Let me run it through completely. So area of sector AOB is equal to 120 was theta. So theta by 360 into pi r square. That's equal to 120 by 360 into pi. What have they given? Use 22 by 7. So 22 by 7 into r square. R is what? 21. 21 into 21. Now see here, guys, very careful. This is something which almost everyone after telling yesterday has adopted, but I think Dinesh and a few others have not yet. Dinesh in one question, yeah. Let us simplify here. 21 7s are. Okay, 3 7s are 3 7s are. This and this. Wait, I'll come to this. This and this will become 1 by 3. Yeah, 3 and 3 go again. 22 into 21. It's 22 into 21 is 441 plus 21 is 462. 462 centimeter square. Okay. Is this correct? Yeah, they have also got the same answer. So my area of segment A, are they named? AYB they have called it. So area of segment AYB is equal to, now write this, sector AOB minus area of triangle AOB. So you have 462 minus 441 by 4 root 3. You have root 3. You have two ways of doing it. You can either calculate this fully and just subtract the decimal, or you can take 21 common out and do how the book tells you. Either way you do it, it's remaining as calculation. Okay. How are you feeling about this question? Now the tricky part here, the only thing which we need to think about is how to, whenever area of segment mostly will be like this only. They will not give you, rarely they will not give you this height. They will not give you length of chord. Okay, that you will have to find. Okay. Or even if they are giving length of chord, then you will have to find radius. So trigonometry will come into the picture. Are you understanding me here? Okay, trigonometry helps us to do what? To find the side, the remaining sides when one side is given. Okay, of a right triangle. All we have to do is make it into a right triangle. How do we make it? We drop a perpendicular from the center to the chord. Okay. How are we feeling about this? Can we run through this process once again in our heads? Yeah. I'm going to use trigonometry. Using trigonometry, I'm going to find this base and this height. See, you can also use Heron's formula. I'm not using that because calculation is bigger. Okay, that's why I'm using half base into head. You can also find AB and then use Heron's formula, root over S into S minus A into S minus B into S minus C. Okay, I just don't prefer that. Why do keep doing all that? Okay, so you find this, for finding this, you found this and you found this, and then this one you multiplied by 2, you found this full thing, half base into height. We good? Once we got that, subtracted it from the area of sector. That's all, guys. We're going to do this question in our notebook now. Okay, this one question we're going to do ourselves in the notebook. I'm going to keep the screen shared. I'll record that part. Okay. You're asking why did we do the congruency thing? Actually, congruency thing is not necessary. Okay, the book does it to get this thing as 60°. Okay, the book uses this thing as 60° and uses that method. But if we go with Tulsi's method, that is isosceles triangle, we don't really need the congruency part. Okay, so either you go through Tulsi's method or you go through the congruency method. Okay, Tulsi's method, I'll just recap. So this congruency part is not needed actually. Okay, I'll tell you Tulsi's method here. Just thank you for bringing that up. So you see this. So Tulsi's method is, this is already an isosceles triangle. That is 21, 21 is already isosceles triangle. So this is going to be 30 and 30. Basically 180 minus 120 divided by 2. Correct? So Tulsi is saying, once you got this 30, why do you need congruency? You put this perpendicular. You take this, you can find, you already know that AM is half the chord because perpendicular from the center bisects the chord. Correct? Just write join OM perpendicular to AB. That's all. Yeah. Thank you, Riza, for bringing that up. Congruency is not needed. The book uses congruency because they don't take the 30° angle. They start taking this 60° angle and they do with that. But we will take this 30° angle. We'll go with Tulsi's method. Yeah. I'm going to give Tulsi 10 points for this. All right, guys, I'll record this part also. So I'm writing all the steps properly here. First, we're showing that the triangle is isosceles. And after we show the triangle is isosceles, we're calculating angle OAB. That's this angle. Sorry. Twice angle OAB. All right. Once we get angle OAB is equal to 30°, we're going to use the triangle. I'll just write the steps. Okay. No more audio. All right. So one thing which I said just now was that it would be nice if you draw the triangle separately. One more important thing is, see, when I'm coming to this triangle now, when I'm starting to talk about this right triangle, I should write in right triangle AOM. Okay. And you don't have to write opposite by hypotenuse. If you want to skip that, you can directly write OM by AO also. If you write opposite by hypotenuse, good enough. Yeah, I will be writing. All right, now that, so everyone is good with these steps. Okay, you will not be doing this part mentally. Okay, even though you are able to do it, you have to write these steps unless and until you are there's a last question you're doing in the exam and you are completely out of time, you can skip that part and directly write this and jump. But this algebraic explanation for how you get angle AOB is equal to 30 degree has to be shown. All right. Yeah, I'm saying I'll not record further from this because after this is clear, I'll just write AB is equal to 2 into AM. Reason is perpendicular from chord bisects the chord, from center bisects the chord. Find AB and then remaining is here. Okay, triangle AOB, you have to calculate triangle sector AOB and then segment. Yeah, and this calculation, do it yourself.